In this video, I will be discussing chemical reactions, focusing specifically on what are called synthesis reactions. When you synthesize something, you're going to combine them. You're going to put things together. So in a synthesis reaction, we're going to take elements or compounds and combine them, put them together to form a single product. This kind of reaction tend to be exothermic. They give off heat. Or more generally, they're exergonic, giving off heat, light, whatever. It doesn't have to be restricted to only heat. For energy to be lost, that means that the system, through the reaction, is becoming more stable and going to a lower energy state. So that's why as they react, that's the driving force. That's what's going to underscore or underpine the reaction. That's what's causing it to actually take place. You can have different kinds of synthesis reactions. We could have a metal and a non-metal react and come together to form an ionic compound. Or alternatively, we could have two nonmetals combine, and of course they would share electrons and form a covalent compound. Let's look at a few examples of synthesis reactions and see how we can go about predicting what the product would be. So in our first example, I'm going to take some potassium and I'm going to allow it to come in contact with oxygen. If you remember when I did a demonstration in the fall with some alkali metals, potassium was one of them. And if you remember, it was stored in a container and under oil within that container, within the bottle. So trying to prevent it coming in contact with either oxygen in the air or with moisture in the air. Okay, so in this case, it's going to come in contact with oxygen. So I've got my two reactants. I've got potassium, of course, is a solid, and oxygen, remembering it is diatomic, one of our diatomic molecules. And so we got a metal and a non-metal, and of course, we're going to get a ionic compound. The formula based on the oxidation states of potassium, group 1 is 1 plus, oxygen, group 6 is 2 minus, and so we have K2O as the compound that forms. Oxides are solids. This is the skeleton equation, so the reaction does happen. And of course, it looks like it's not balanced, and so I put in the appropriate coefficients, and we end up with this balanced equation. So a metal and a non-metal, they'll combine. They'll use language to indicate that the reaction does take place. And if it's metal and non-metal, of course, ionic compound. Long ago, you learned how to write the formulas for ionic compounds. Let's look at another example. Sulfur is often mixed in with coal. Whenever coal is mined, there are certain kinds of coal that have high sulfur content. So when you burn the coal for energy, the sulfur that's mixed in is also going to react with oxygen. And sulfur, of course, is a solid. Oxygen, again, a diatomic molecule. And one of the possible results of their reacting is sulfur trioxide, which is a gas itself. So obviously this is a covalent compound, two nonmetals. The equation, the skeleton equation, is not balanced. I go through and put in the appropriate coefficients, and I end up with my final equation. So when you've got two nonmetals, we know there are different ways for them to combine. So you're often going to have to either through experience know what's going to be produced, or there'll be enough description to give you clues as to what will be the product of them. Otherwise, it would be very difficult for you to know precisely what's going to form. Now let's look at one final example, a third example, and let's use that sulfur trioxide. So we burn the coal, which causes the sulfur that might be contained in the coal to also combine with oxygen. Sulfur trioxide would be produced. It's going to be released into the air. That would be part of the exhaust of the furnace that has the coal in it that's burning. And if it comes in contact with water in the atmosphere, it will react, and we will form H2SO4, which of course is sulfuric acid. And this is the basis for what is known as acid rain. So some kinds of coal can have really peripheral environmental impact because of the sulfur content. The sulfur trioxide that gets released can lead to the formation of sulfuric acid. So when it rains, the water that falls on the ground is going to be pretty acidic because of the sulfuric acid that has formed. So a key environmental solution would be to try to remove the sulfur before the coal is burned, or to capture the sulfur trioxide before it is released from the exhaust. Okay, but again, this was a synthesis or combination reaction. Some of these are a little more difficult to predict the products. Metal and nonmetal, not so difficult. You know you're going to get an ionic compound. But two nonmetals, the covalent compounds, unless you have enough experience and maybe have read about specific kinds of reactions, it would be hard to predict the product. So that is synthesis reactions. The system becomes more stable. These tend to be exothermic or exergonic.